So in this question, you see one block is placed on another block and the upper block is attached with a string. So in this question, you have to find out the minimum force required to move the block Y, all right, and the tension T in the string immediately before the block Y. So one important thing to note that the coefficient of static friction between blocks and the Y is zero point 0.2. Okay, so it means that there is a friction between these two blocks as well as between block Y and the ground, which we will include in our free body diagram. So the one very important first step is to draw the free body diagram, and why not start with X? So I'm going to draw its free body diagram here and we will include all the forces exerted on X. So this is the block X, we assume, and I am showing it in our rectangular coordinate system where you see there is a force of tension in a string. So I will draw a vector towards right. Okay, so this is a force of tension. Now since this block is at rest, so that how much force will be applied on Y so that this block is at rest. So it means that when you will be applying force in this block Y, just imagine you are pushing this Y to the left side. Where is the tendency of this block X to slide, which is of course it can slide in this direction. So to counter this sliding effect, the force of friction must be in opposite direction, and also to keep at rest the force of friction must be in this direction. So this is a force that I can say is applied by Y on X. Okay, I'm using the small letter F. Whereas what are the other forces? The one force that is exerted by the Y, which is the normal force. So this is a normal force, whereas the same amount of the force is the weight, and let's say mxg is the weight of the block section, which is balanced with each other. So in this question, we can say that the force of tension Ft is equals to Fy on X, which we know that according to the formula of the force of friction is always mu s, coefficient of static friction, because X is at rest, times the normal force. Okay, the normal force exerted on which block? On this block, right? So if we put the values, so then it is equals to mg. All right, you see very clearly that this force and this both are equal, and when we will put the values, which is of course 0.2 times what is a weight, that's a 10 newton, so it is 2 newton. It means that the 2 newton is the force exerted at this, which is equals to this force minus 2 newton, because that is towards left. Okay, now let's find out the minimum force. So students, for this we will draw now its free body diagram. Okay, now for the Y, you have to keep in mind that the Y is experiencing two frictional forces. All right, which one are those two frictional forces? The one force that is exerted by X on Y, all right, which is which should be in which direction? You remember I told you this is a force which is exerted by Y on X. So Newton's third law says that two action and reaction pair have a same magnitude but opposite in direction. So it means that its reaction pair or its pair must be in opposite direction. So I will draw the same length of this vector. So I am going to say it X on Y. All right. What is the other frictional force? The other frictional force is the force exerted by ground, all right, on the Y. So G on Y. All right. So when they are saying find the minimum force, it means that minimum criteria is that this force will be equal to sum of all forces which are exerted on the right side. Why I'm saying it? Because students, this is the only force which is exerted towards left. You understand? This is the only force that is exerted to the left, that must be equals to sum of all forces which are exerted to the right. Okay, So do you understand by this equation? All right, this is the criteria, this is the standard of minimum force. Otherwise this force must be larger than if you want to accelerate y. Okay, now what are the other forces? Let's draw them quickly. The other forces, this is a weight of the, I mean, this is a 10 Newton. You understand? This is, of course, the weight of the upper block, and this is a weight of the lower block, that is MYG. All right. And if you add up these two weights, then together this will be the normal force exerted by the ground on the Y. All right. So that must be equals to sum of these two forces. So I'm calling it, it's also a normal force. Okay, so we had already calculated this force was 2 Newton. Okay, whereas what will be this force? This is also a frictional force, so that must be equals to mu s normal force, right? So how much it should be? 0.2 into normal force is the sum of two weights. All right, sum of two weights, which is 0.2 into 10 Newton plus 20 Newton given in the question. I hope you understand these two. So it should be 0.2 into 30, and that should be 6 Newtons. All right, now we are at the stage when we know all the frictional forces applied on the x and applied on the y. Let's put them in the equation. So minimum force must be equals to 2 Newton applied by x on y plus this frictional force, which is 6 Newton applied by ground on the block y, and together it's answer 8 Newton. So this is our final answer, and that's why 8 Newton and 2 Newton. So the right answer should be